In this mini tutorial, we're going to consider an idea known as cranial nerve hitchhiking. And this is a very important principle which we can use to try to understand the way in which autonomic fibres are distributed throughout the head. Now, autonomic fibres, particularly postganglionic fibres, have a problem. And that problem is that they're unmyelinated, meaning that they tend to be rather weak and relatively easily damaged. And what this means is that they like to travel alongside other cranial nerves to give them something to support them, essentially. And the cranial nerve which many of these autonomic fibres use is the trigeminal nerve. So in the rest of this tutorial, we're going to look at how autonomic fibres exploit the trigeminal nerve to distribute themselves throughout the head. Now, we're going to draw a simple diagram, but let's introduce the colour scheme that we're going to use. We're going to use red to represent motor fibres. We're going to use blue to represent parasympathetic fibres. We're going to use green to represent sensory fibres. And we're going to use orange to represent sympathetic fibres. So that's our colour scheme. What we're also going to draw on is a region of the brainstem where a hypothetical cranial nerve emerges. And we're also going to draw on the pons here where the trigeminal nerve emerges, the fifth cranial nerve. So let's consider our hypothetical cranial nerve. We're going to say it has a motor component within somewhere in the brainstem. It's got a motor component, and of course that motor component is going to travel all the way to the ultimate target, which of course is going to be a muscle. All right. So this could, for example, be the oculomotor nerve, and the muscle in question could be various extraocular muscles. Additionally, we can add on to the diagram sensory fibres which are coming into the pons through the trigeminal nerve. So here's some kind of sensory receptor in the skin of the face, for example, and this is entering the pons via the trigeminal nerve. Now, associated with each division of the trigeminal nerve is a ganglion, and we're going to draw that ganglion on here. So essentially, hanging down from each division of the trigeminal nerve, we have a ganglion. And this ganglion will become important because it's going to be the site of synapse for parasympathetic neurons. So let's draw on some parasympathetics, and we've said we're going to use blue for our parasympathetics, and this is the source of our hypothetical parasympathetic fibres. If this were a real example, it might be the Edinger-Westphal nucleus in the midbrain, which provides parasympathetics to the oculomotor nerve. Now, those parasympathetics run for some part of their course along this cranial nerve. But there comes a point where they actually leave that cranial nerve and go down into one of these ganglia associated with the trigeminal nerve. So this is a parasympathetic fibre which has been travelling alongside the motor fibres in our hypothetical cranial nerve, but now the parasympathetics have left that cranial nerve and have entered one of these ganglia associated with one of the branches of the trigeminal nerve. Within the ganglion, they synapse upon a postganglionic neuron, and are then distributed to a target. And that target could, for example, be a gland. So what I've just demonstrated to you is an example of cranial nerve hitchhiking. This parasympathetic fibre has left its parent cranial nerve and has hitchhiked alongside a branch of the trigeminal nerve. It's now travelling with the trigeminal nerve, not with its original parent cranial nerve. Now let's consider the sympathetics. And you should recall from a previous mini tutorial that most of the sympathetics get to the head by travelling along the walls of blood vessels. So here's an artery which I've drawn on here, and this could be a branch of the common carotid artery, for example. And as we've said before, the sympathetics run along the walls of arteries, and at some points they leave those vessel walls and join up with cranial nerves. So in this case we've depicted a sympathetic postganglionic axon which has left the wall of an artery, and now it's joined up with one of these branches of the trigeminal nerve. The sympathetics then run for some distance along the trigeminal nerve, passing through one of its ganglia, but note, not synapsing within the ganglion. And then at some point distally they'll leave the trigeminal nerve and make contact with one of their targets. Now we can see, once again, as in the case of the parasympathetics, in the case of the sympathetics, they hitchhike for some of their course along a cranial nerve. So the sympathetic fibre here is joined up with a branch of the trigeminal nerve, and then it's left at some further point to reach its target. So both parasympathetics and sympathetics hitchhike along cranial nerves. Now, in thinking about the way that the sympathetics get onto our branches of the trigeminal nerve, there's a very important region which I want to draw your attention to, and we're going to draw the wall of this in purple. And that region, which is important for getting sympathetics onto branches of the trigeminal nerve, is known as the cavernous sinus. And the cavernous sinus is one of the dural venous sinuses sitting down at the skull base. And it's a very important region because this is where we've got a lot of cranial nerves and blood vessels all concentrated together. And this provides us with a great opportunity of getting sympathetic innervation onto cranial nerves. So the cavernous sinus is very, very important. Now, the last thing which I just want to cover is a little more detail on the ganglia associated with the trigeminal nerve. And there are three branches of the trigeminal nerve, and they have three associated ganglia. So, as you should recall, we've got 5A, the ophthalmic division of the trigeminal nerve, 5B, the maxillary division, and 5C, the mandibular division. And each of these branches has associated with it a different ganglion. So 5A has got the ciliary ganglion sitting within the orbit. So the ciliary ganglion is associated with the ophthalmic division of the trigeminal nerve. 5B, the maxillary division, is associated with the pterygopalatine ganglion, and the pterygopalatine ganglion is quite difficult to find. It's sitting quite deep inside the skull in the pterygopalatine fossa. And 5C, the mandibular branch of the trigeminal nerve, is associated with the submandibular ganglion. So each of these branches is associated with a separate ganglion. Now, I hope that this has been useful. In future podcasts, we're going to look at some specific examples of autonomic innervation to the head, and we're going to be using these principles which we've learned many times to understand the precise details. Okay, thank you.